Here we're going to look at how we can convert rectangular and polar equations. And just as a reminder, we're going to use the same formulas we had before, where we had x equals r cosine theta and y equals r sine of theta. And then, of course, we have x squared plus y squared equals r squared. So these are the three main equations that we'll use here when we're converting actually rectangular and polar equations. The previous video we were looking at converting only coordinates, but now we want to look at how can we convert an equation from rectangular to polar. So for an example, if we had the simple equation x squared plus y squared equals 16, this is a rectangular equation and we want to convert this to a polar equation. And to do that, we're simply going to use the formulas over here. Well, we want to substitute in, so that means we want to cancel out x and y and change everything to either r or theta. Well, this one's going to be easy enough because we have x squared plus y squared, and over here we see that x squared plus y squared is simply equal to r squared. So we can substitute that whole piece in for x squared plus y squared, and we get r squared is equal to 16. Then of course we would simply take the square root of both sides and we would end up with r is equal to 4. And of course here it could be plus or minus 4 when we take the square root, but here we're going to think of this as being a positive 4, and this is going to be in our polar form. So this is the polar equation for x squared plus y squared equals 16. Now, do you remember what x squared plus y squared equals 16 is? Do you remember what that graph is going to look like? Well, if not, can we figure out what the graph of r equals 4 is going to look like? Well, if we think about r equals 4, imagine if we were to take and make a chart of r and theta, just like we would make an xy chart. Well, we could plug in values for theta. What happens if theta is 0? So what if theta has an angle of 0? Well, there's no theta over here, so r is going to be equal to 4. What happens if our angle is equal to pi over 2? Well, once again, there's no theta, so therefore r once again is 4. What happens if our angle is equal to pi? Once again, r is 4. So if we think about this, what's the graph going to look like? Well, if we're thinking of our graph here, basically we're saying r is always 4 no matter what angle we are. So therefore we're actually going to end up with a circle that has a radius of 4, because we're saying the angle at which we go around doesn't matter. We can have any angle that we go around, but we're always going to go out a fixed distance of 4, and that is certainly describing a circle. And if we go up here and look at x squared plus y squared equals 16, that is the equation here for a circle. If we have x squared plus y squared equals r squared, r squared, that is the radius, or r is the radius of a circle, which is a radius of 4. And this is the advantage of using polar equations. You're probably thinking, well, we have these rectangular equations, why do we want to use polar? Well, if we compare x squared plus y squared equals 16 to the equation r equals 4, r equals 4 is a lot simpler to come up with the equation for a circle. For one thing is, we only have one variable as opposed to two variables. The variable is not squared, it is simply r equals 4. And that is one reason that we have the polar system, so that we can simplify some of these equations that we have, particularly those that are centered at the origin. And you'll find out that a lot of times that will make it an easier way to represent the equation. So once again, to convert this, we simply used over here x squared plus y squared equals r squared to substitute that in to convert to polar form. Now again, when we had r equals 4, we can kind of relate this to if we had the equation, for example, y equals 4 in rectangular form. If we go to make a little XY chart for this, we can pick values for x. If x is, say, -1, 0, 1, or 2, what's the value of y? Well, just like this rectangular equation, there is no x-coordinate. So here, this is saying y equals 4, so y is always going to be 4, which means we have our constant function. So if we look at the graph, we're going to get a horizontal line at 4. So that's kind of the same idea over here with r equals 4 in polar, where we're getting the radius, the distance from the origin, or the distance from the pole, is always 4, no matter what the angle is. Okay, let's try another example. And we have the equation y equals x. And once again, we want to change this rectangular equation to a polar equation. And if you're confident enough, maybe you want to pause the video and see if you can figure this one out. And once again, we're going to use the idea of the equations we did before. X equals r cosine theta, y equals r sine of theta, and of course x squared plus y squared equals r squared. And this is just going to be a basic substitution. Well, we have y. Well, y is equal to r sine theta, so that becomes r sine theta, and x will become r cosine theta. And at this point, you notice we have eliminated y and x. The equation now is simply in terms of r and theta. And that's exactly what we want. Now, we're probably going to simplify this a little bit. And to do that, here we need to be careful. We can actually divide both sides by r. And if we do that, we'll end up with sine of theta is equal to cosine theta. And here, if we divide by the cosine function, to rearrange this a little bit more, notice now we end up with sine over cosine, which is our tangent function. And then, of course, cosine over cosine divides out to 1. And we can even go a step further here. To get rid of the tangent, or to solve for theta, we could take the inverse tangent. So what we could do here is we could actually take the inverse tangent of both sides. And if we take the inverse tangent of both sides, then we're going to be left with our angle theta equals the inverse tangent of 1. And if we put that in the calculator, you could simply do that. Or again, if you think of your unit circle, where on the unit circle do we have y over x equal to 1? So we're looking on the circle, where is y divided by x equal 1? And we'll notice that's going to happen right here at the angle pi over 4, because we have square root of 2 over 2 for your x and your y value. So therefore, the angle, we could say, is equal to pi over 4. So here we have basically eliminated the variable r, so this polar equation is simply in terms of theta, whereas the one before was simply in terms of r. So what do you think the graph of this is going to look like if we simply have theta equals pi over 4? Well, once again, you could think of making a chart where we have r and theta. And here we could say, well, what happens if r is 0? Well, theta is going to be pi over 4. What happens if r is equal to 1? Well, the angle theta is still going to be pi over 4. So what we're going to notice is it doesn't matter what r is. R could be a -1. The angle is still pi over 4. So what does that tell us? Well, if we rotate around to an angle of pi over 4, basically then that means we could go out any distance positive, or if r is negative, we would go the other direction. So here, if we have theta equals an angle, we actually end up with a straight line. because it says our radius, we could go out any distance from the pole as long as we're at this angle of pi over 4. And if we go up here, we can double check this. If we look at the equation we had is y equals x. Well, that's the identity function. And basically what that says, whatever x is, y is. And that would be a straight line here right through the origin, just like theta equals pi over 4. So that's one way you can always double check to make sure that you ended up with the correct answer is go back and look at the rectangular equation and see if that matches up with the graph of the polar equation. They should be the same. All right, one more example. We have 4x plus 7y minus 2 equals 0. So here again we have a rectangular equation we want to change to polar form. And we're still going to use x equals r cosine theta, y equals r sine of theta, and x squared plus y squared equals r squared. So here we're just going to substitute in. We have x, so in place of x we could substitute in the r cosine, so we would have 4 r cosine of theta plus 7 times y, which happens to be r sine of theta, and then we simply have minus 2 equals 0. We could factor out the r. If we because here each piece has this r in common, and I guess before we do that we have this minus 2. Let's move the 2 over, so we would get 4r cosine theta plus 7r sine of theta. So we want to move the 2 over. So now the object we want to do first here is we now have all the terms on the left contain an r, which means we can factor out the r, and we're left with 4 cosine theta plus 7 sine of theta. And keep in mind, that's typically what you want to do. If you have your variable here, like we do at this point where it's tied up with two different terms and we can't combine the terms, then you typically want to get these two terms, in this case, by themselves. So that's why we wanted to move the negative 2 over here. And then we can always factor the r out front, because now we have strictly multiplication, which means we can now divide everything else away. So if we divide away, we're left with r equals the 2 divided by 4 cosine theta plus 7 sine of theta. And really at this point, this is about all the simplification we can do for this. So this would be our polar equation for the rectangular equation 4x plus 7y minus 2 equals 0.